All right, here we are with Mike from Noyes Development. And Mike, could you introduce yourself?
All right, I'm Mike Fry with Noyes Development Company. Noyes Development's a local Portland area home builder, and we've been in business since about 1993. We're focused on building in the Bethany Cedar Mill area. It's kind of where we call home, and we build about 50 homes a year right here in the local kind of Bethany Cedar Mill market. And we focus on high-end spec homes, and we build high-performance homes. So a lot of our homes, almost all of our homes, are Zero Energy Ready certified by Earth Advantage, and all of them receive an Earth Advantage Platinum certification. So some of our priorities include making sure that what people see is what they expect, but we also want to make sure the things that they don't see are as impressive and well put together as the finishes that they can walk into any home and see. We believe that the things behind the walls matter actually more than the things that are finished in the end product. We've always been about building good homes. Through our continued study and evolution of what we do, we were able to take some of these green building practices and realize these aren't just for a select group of people who really care about the environment more than others or something. These practices that we put in place just are part of building better homes. We should be doing these things naturally anyway, and it's something that I think our customers are starting to see and other builders are seeing, that if we want to be proud of what we do, build something that's going to last, these are just common sense principles that we should be looking into and then using. For our customers, we see a lot of different approaches for why they choose what they choose. A lot of people are just initially shopping based on location, home size, schools, some of those things. So that's going to be a common factor that you're going to see anytime you're selling a home. Then showing them the difference that you can bring as a builder and that we bring as a builder is where it becomes really important. So we're able to highlight that we're going to be able to build them a home that's going to be more comfortable, a home that's going to be healthier, a home that's going to be more durable, because it's a huge investment. You want it to last. And a home that's going to save them money every month, and a home that they can feel proud of. Which ones of those reasons people latch onto the most can be different. I think we find a lot of people being really interested in health and comfort. Not surprising, right? Some people are going to focus in on the monthly savings. And then at the end of it, I think people just really do feel good knowing that they're a part of something that's more sustainable and it's better for our community and our world.
That's awesome. Yeah, I really like how you break that down. The old conversation was about energy efficiency and talking about the dollars and cents. And I really like to hear how it's transitioned into those health and comfort benefits and durability overall, right? And so that to me seems like it's a much more evolved and mature conversation around how these are just better buildings, which I think is what it sounds like this is all about, is just achieving a higher standard. And that's pretty awesome. And then with these particular homes, it sounds like a lot of them are going to be Zero Energy Ready, if not all of them.
We're building almost all of our homes to a Zero Energy Ready standard now. A few years back, we started to realize we're really close to meeting that standard just with what we were already doing. So we started to be a little more intentional in some of the planning that we put together. And we still have some challenges sometimes where we either have some beautiful trees that are providing a little too much shade for the house, or as we're trying to keep some architectural variety to the neighborhood, sometimes roofline doesn't quite maximize the solar potential that we have there. But almost all of our homes at this point are getting that Zero Energy Ready certification from Earth Advantage. We've been able to put solar panels on a couple of our model homes to just show people this is a zero energy home. We're standing in a zero energy home right now. And I think a lot of times people don't realize that something that they can have today in a kind of traditional neighborhood. It's been really enlightening for people to see an actual installation, and it's allowed us to drive more leads to our solar partner and actually getting panels on the homes for more zero energy homes, not just Zero Energy Ready here. All right, Stefan, so we're in one of our model homes here. Let's walk through and just check out some features and talk about the home.
Excellent.
We have some controls for our HVAC system. So we use Mitsubishi heat pumps in all of our homes. They're a variable speed, really high efficiency heat pump. and they can heat and cool the home year-round, no matter the temperature. And we also have an alarm system that provides some different home automation options for people. This system can be used in conjunction with garage door openers, smart light switches, speakers, all kinds of different things. A few of the options that we include that can work with it are the garage door opener. The irrigation controls can actually be linked to it, and some of the lighting controls, their additional options can be. Next to it, we're going to actually transition to some more mechanical equipment like we talked about the thermostat here. This is just a nice little example that shows all the ductwork for the home is inside the conditioned space. It's running inside these floor systems, above us. And by having all that in here, we're producing greater efficiency and greater health for the home. And it's kind of amazing to think that we actually have a bridge above us, essentially. And even with this section here that you would think it'd be hard to get all the ductwork across, we're able to keep all the ductwork inside the conditioned space of the home. Now, if you can do it in a home like this, where you have a bridge as a pass-through, and it's not just a simple stacked two-story home, you can do it in any home.
Yeah, my understanding is you can lose about 30% of your home system's energy performance just by having leaky ducts that are outside of the building envelope in an attic or in a crawl space. And so what this does is it really creates a much tighter system, and if there's any leakage, it's to the inside conditioned space of the home.
Absolutely. So we seal all the ductwork, we size it, and we run specific calculations for every home to make sure that we're getting the right amount of airflow to every room. But if we do have a little loss in between, like you said, it's just all going to the home anyway. And this is one of the most critical steps to building a really efficient home and to meeting a zero energy ready standard.
So where are you putting the furnaces for this?
So we actually can go upstairs and take a look. We, depending on the plan, we find different locations for them. A lot of our plans, we put the furnace in a closet in the laundry room. Right. Excuse me, the air handler, not the furnace.
So, Mike, my understanding is that you're using these advanced Mitsubishi heat pumps as essentially your new furnace. Can you talk a little bit more about that transition and more about the equipment?
Yeah, so as we transitioned into building zero energy ready homes and we realized that we were producing this standard, we kind of started to evaluate whether or not it made sense to have gas furnaces in our homes. If I was going to tell people that they could offset all of the energy use in their home, but then pay a gas bill, it just didn't feel like the right balance to me. So we started evaluating heat pump options. And now some people aren't familiar with heat pumps, but a heat pump can both heat the home in winter and cool the home in summer. So older heat pumps were not as efficient, couldn't operate in lower temperatures. Newer heat pump technologies can operate year-round. You can get down to even below zero temperatures with some of the units that are out there, or just very cold temperatures that we don't have to worry about in Portland. And they can efficiently heat the home. Then in the summer, they're actually more efficient than most air conditioners for cooling the home. So having that as an electric-based heat source and cooling source made a lot of sense when thinking about pairing things with solar. So we use these really high efficiency, variable speed Mitsubishi heat pumps. And they're very small and compact and quiet. We still run ductwork throughout the house, and we have an air handler that we locate inside the home that is essentially just a giant fan that is able to distribute that air to the home and the conditioned air to the home. So most of our homes, we locate this air handler inside a closet in the laundry room. Sometimes our plans have different locations for that. But we also put some insulation around that room and a solid door so that there's no noise concern from the air handler's big fan being inside the home. Additionally, because this is a variable speed unit, that means that the fan doesn't run in only one speed or only two speeds. It's able to cycle up and down, and the compressor is able to cycle up and down as needed. It's a lot quieter and it's a lot more efficient as a result.
Yeah, it's awesome. I think maybe some folks don't realize that a real basic heat pump that's been in their home for years is a refrigerator. And so one way to think about that is that, that refrigerant is being used to pull energy out of your food and milk and things like that, and then you're expelling that in the back of the refrigerator. So you feel like that hot side of the heat pump is the back, the refrigerator typically, and then the inside is kind of the cold side. And the cool thing about this Mitsubishi is what it sounds like. You have an outdoor compressor, and so then you've got an interior kind of condensing unit, so a bunch of coils in that air handler in there. And so in the summer, we're going to take the heat from the home, we're going to pump it out to that outdoor unit and expel it. And then in the winter, we're going to take the heat from the outside, even when it's kind of cold out, and we're going to find some of that heat, we're going to bring that and pump it into the home. So that's kind of the essential of the heat pump. My understanding with these Mitsubishis is that they're 11 HSPF. And so that kind of translates to real basic terms that you have essentially 1 kilowatt of energy in, and you're getting like 3.5 almost, between about 3.4 or so kilowatts of energy out of the system. And they're getting the rest of the energy from the air essentially, and the refrigerant cycle system. So I think that's also really important too. So if you've got somewhere in that 3.5 zone of kilowatt output for 1 kilowatt in, that sounds like 300% plus energy efficiency, right? That's pretty amazing.
Yeah, Stefan, that's a great explanation of the whole process. Buy one unit and get the benefit and production of 3.5 or so units of energy. It just makes a lot of sense.
And to be fair too, natural gas is quite a bit less expensive than electricity, and of course we lose a lot of electricity when we manufacture it with natural gas or other types of products at the plant. And so my understanding is that we lose somewhere in the realm of 200% or so, 270. We have to get to the point we're essentially losing 70%. When you reverse that math, you need a heat pump that needs to be 270% efficient or higher to be efficiency of 100%, let's say, natural gas. And when you're at 300%, you actually are.
Yeah, I think we're fortunate in the Pacific Northwest that we have a lot of clean energy being produced, but it's true that a lot of the electricity that we're buying is actually produced through natural gas use. But when we pair the electric heat source with solar panels on the roof, we can directly be sending the energy that we need from our roof to our equipment, and kind of cutting out the middleman, if you will, for so much of the year. And we are grid reliant, we're still connected to the power grid, but for a lot of the times during the day, the sun is shining. Even when it's cloudy, we get great solar production, and we're able to take that energy and just send it straight to the home for use.
So essentially these developments are renewable energy providers. It's almost like this Noyes development becomes a kind of micro renewable energy solar provider to the rest of the grid.
Absolutely. So through the net metering process with the utility companies, we're creating this energy on the homes. We're using some of it. A lot of it we're not using in real time in the moment. So we're just sending it right back to the utility companies as clean power. This clean energy is going right back to PG in our case. And then we're able to pretty much just put that in a bank account of power. And so all the energy that this home produces, if it's not using it, it's going into the bank account. And then when we get days that aren't as sunny or they're colder or we're using a little more energy, we can just draw from our bank account. And for a zero energy home, at the end of the year, all of that equals out to where you've put enough money into the bank or enough energy into the bank that as you draw it back out, you're equal at the end of the year.
So you're netting zero in that
Netting
case.
zero. Yeah.
Fantastic.
So here we have a central vac system. There's a hide hose. There's a concealed hose inside the wall here. And we have a little card that can show people. But one of the benefits to this is central vac. Typical vacuum kicks a lot of the stuff back out into the air as you vacuum. The central vac makes sure that everything goes out to a sealed container and is exhausted outside from the house. And this is super convenient because we have a hose that just extends from the wall and then will retract back in to be hidden and out of the way. So with kids in the house, this is really useful because they can actually clean up their own messes. And knowing that the indoor air quality is improved from this is really an added benefit.
My understanding is that you rough-in those systems for all of your homes, and it's an option for your clients. Is that correct?
Yeah, thanks for clarifying that. So the actual finished system is an upgrade option. It's easy to add on after the fact, but we do the pre-plumb, which is the part you have a hard time going back and doing later. We do that standard in all homes.
So that's really, really excellent. Great. So we're here in the mechanical area, and we're looking at a 97% efficient gas hot water heater. It's made by Navian, and it's pretty awesome. It's condensing, and it's about as efficient as you can get for on-demand hot water with natural gas. And then over here, we've got this vacuum flow central vacuum system, and that's pretty awesome too, especially for indoor air quality. And the cool thing about it is usually when you vacuum a home, you've got that bag that's inside the vacuum that filters out the air that you're pulling from the carpet or the floor or whatever else. So as that air comes up into the bag, little bits of it get out. So little particulates and whatever else kind of suspend up into the air again. So you're kind of like recirculating dust into the air. Whereas a central vac has this motor vacuum outside, typically in a garage, or its space is loud, so the sound to be outside of the main space. But we have this thing sucking air when you hook up your hose inside, and then it's going to blow that exhaust air outside. And so that fine particulate kind of leaves the house and then blows out into the outdoors, where it can kind of deal with that fine particulate through leaves and whatever else out there, and not through your lungs inside. So pretty awesome. All right, so this is a Solar Edge inverter. It's pretty awesome. So you're taking the direct current from the roof, the solar panels, and we're inverting that into alternating current. And then you can use it for really cool things like this car charger. So that's pretty sweet. And the Noyes has this option on all of their homes, which is pretty awesome. So they're rough and ready for all of this equipment. This is an example of when you actually do install the full equipment. And so being rough and ready for it all is kind of a solar, zero energy ready home. And so we're going to talk a lot about that. But yeah, in this particular case, we've got somewhere around 10 kilowatts of solar power up on the roof. And that should offset all of the electricity used on site in this home on an annual basis, if not even a little bit more. And provide that extra energy to really cool things like your sweet new Tesla.